All right, so Tornjak, and thank you for the comments on the previous presentation. We should definitely take this further on conversations within the community. Let's discuss on one of our channels, and we're happy to dive into some of the details. Nevertheless, I'm going to continue with the presentation as is, the status of Tornjak today. So, before I start, I want to acknowledge that we think the SPIFFE and SPIRE are great. We love it. And I'm sure you do it too, since you've been here and paying attention. So SPIFFE and SPIRE provide us with the zero trust security architecture. The best part is they remove the hard-coded credentials like long-term API keys, passwords, and so on. This simplifies the automation and scaling the large deployments because we can now use what's called worker identity for setting up the access policies, especially across various platforms and multi-cloud, multi-cluster deployments, and so on. SPIRE allows us to integrate nicely with the provider-specific attestation. And of course, there are much more use cases that we covered already today. So quick view on how this typically works. User accesses the SPIRE server deployment using CLI interface. This way, she can view and manage various identities coming from SPIRE agents that are connected to the SPIRE server, and that's pretty cool. However, there are a few challenges with this model. The management of the large number of instances is difficult and time-consuming. When the organization contains the SPIRE deployment across various clusters and different locations, keeping track of several SPIRE instances, all the agents, entries is hard and often error-prone. So we need a custom tooling for managing the SPIRE at scale. Also, in order to manage SPIRE, users need a direct access to the SPIRE environment. We need an easy and intuitive interface for managing complex identity tasks. Basically, we need a scalable control plane for SPIRE. So this is why the project Tornjak was born. So Tornjak is a control plane for SPIRE, and it's also an easy and intuitive graphical user interface for managing the SPIRE artifacts, the identities, and so on. It sits between the user and the SPIRE server. So quick history, the name Tornjak comes from the herding dog breed in Central Europe. Basically, it's a dog to manage the livestock, like the pets versus cows metaphor for containers, well, in this case, sheep. The main person behind the initial Tornjak architecture was Brandon Loom. Together with Brandon, we wrote the first code and donated this to CNCF SPIFFE SPIRE community about a year ago. Later, Mohammed and then Maya joined our team, and they are now active contributors to this project and the community. So let's take a closer look at Tornjak. Tornjak is actually composed of two main components. There's a Tornjak front end, that's the React application with TypeScript, and Redux for state management, all running in a browser. This application organizes and displays metadata and the SPIRE information to a single user. Additionally, it translates the user input into Tornjak API calls. Then they are passed back to the backend. Tornjak backend, this component written in Go, is tightly coupled with the single SPIRE server instance, and it's deployed directly within the same container. It receives Tornjak API calls via the web server, then handles and executes the flow and forwards them directly to SPIRE server. Accessing the backend merely requires access to its web service. The communication between Tornjak and the collocated SPIRE server is done securely via host socket. So Tornjak becomes a proxy between the remote user and the SPIRE. User doesn't have to be physically sitting at the host. We also have a database to store Tornjak-specific metadata like cluster information, plugins to support extended functionality, etc. Another feature of Tornjak is what's called Tornjak Manager. This is a single interface to manage several Tornjak instances and indirectly several SPIRE server instances. So here, you basically configure access to each individual Tornjak instance, and then you can see it on a single portal, different Tornjak/SPIRE instances, and manage them from one location. So this is the example view of the agent list. So from here, you can view, you can delete and ban agents or assign the workload attesters. Here is the entries, the view of the entries. You can view and delete, import and export all your identity entries. Tornjak also provides a capability to create entries. So we support a feature to upload an entry template for a single or multiple entries and easily manage them based on the environment characteristics. We, for example, provide a template for quickly configuring the workload registrar entry with the admin privileges, which is typically used for auto-creating identities based on specific custom identity schema. And here it's a cluster view. So now you can create custom clusters and assign specific agents to the cluster for management as an entire group. Once you have this done, you can then view them on a dashboard where you can see graphically all your clusters and all the agents that belong to each cluster. Then you can go a deep dives and you can click through all these sections and go and get the details of individual instances. So back to our high-level Tornjak project. So all good, but anyone who has direct access to Tornjak URL could easily modify and make changes to SPIRE. So the Tornjak must be either protected by a firewall or some additional internet that is separated from the rest of the world to prevent SPIRE modification, unless we introduce the authentication and authorization functionality to manage the access to Tornjak. So since the user management is already a well-known process, we decided to integrate with the existing solutions instead of writing this all the way from scratch. So the only requirement is we need to have a reliable access levels, like for example, admin, to manage and configure identities or agents and so on. So to have actionable operations. And then we have a viewer role, which basically allows simply viewing information, listing agents, clusters, identities, and so on. So what we did, we extended our Tornjak to support auth2 IAM. So for this purpose, we used Keycloak. And Keycloak, it's a very popular open source identity access management solution that allows management of users, their roles, privileges for accessing the specific systems and applications. It has plenty of customizable features, and it supports standard protocols like OIDC. So in this case, Keycloak is just the example for IAM integration. And this model works with any other auth2 identity and access management, including Amazon and so on. And in fact, we are doing some experiments right now with Amazon and then Azure Active Directories for proving that the integration should work right now. So how is it done? CISO or admin sets up the realm for Tornjak and populates it with some user IDs that would be used for this experiment using two roles, a role for the admin and for the viewer. Then the admin needs to configure the Tornjak backend just by simply enabling the user management and point it at the specific IAM. So now Tornjak backend can validate all the incoming calls by verifying them against the public keys that are published by IAM. Tornjak front end now connects to the IAM service to handle all the authentication aspects. So when the user connects to Tornjak for the first time, they would be redirected to IAM to establish the authentication. So upon successful authentication with standard user ID and password, there is an access token generated and then is provided back to front end. Tornjak front end now would be using this token to make calls back to backend. The backend only validates the token with the IAM, and then it verifies whether the specific role defined inside the token allows for executing the specific Tornjak API operations. If all is good, then the call is handled and passed all the way to SPIRE. So of course, the time to live for the token could be configurable. And once it expires, the new token must be obtained. So the front end would handle all this operation. Everything I just explained is well described in the blog article, Identity and Access Management Integration with Tornjak. I provided the links here in the presentation as well as in our Tornjak Slack channel. So our next blog, which we are almost completed, would be discussing the details and scenarios of how to configure the key clock to be easily integrated with Tornjak to do the user management. And now, since we have a direct and secure remote access to Tornjak and indirectly to SPIRE, we can do something else pretty cool. So we could make now remote calls, remote secure calls to SPIRE. All the Tornjak APIs can be easily accessed programmatically through, for example, like simple curl commands. As long as we have a valid access token, also known as a bearer token, we can now call Tornjak backend directly and remotely. For example, if our tooling discovers that some node has been compromised or it failed some additional security attestation, we can make a call through Tornjak and ban the compromised agent. As a result, all the identities that are handled by this specific agent would be automatically revoked. And that's pretty cool, I think. So in fact, our team has a lot of experiments with keyline remote attestation that dynamically bans agents that are problematic, but this is a subject for another separate presentation since we don't have that much time today. So of course, please, you always can reach out to us on keyline attestation. If you're interested, we will be happy to discuss it. Okay, as the current state is now, Tornjak is well controlled, but beyond Tornjak, once we have a SPIRE APIs, there's no authorization. So we are looking towards some possibility of pushing this line all the way to SPIRE level. And we have already engaged the SPIRE community in the past into some conversation about how to do it. I know it's not easy, but this is on our agenda. Okay, so I want to add that our team is also open source. We also open source the Helm charts that are related to Tornjak. We split the front end and back end into separate images. We package Tornjak with SPIRE server for various platforms. So, for example, we support Kind, Minikube, OpenShift, and some other various cloud providers. Our scenario includes multi-cloud and multi-cluster deployments. We also did extensive work on some of the attestation scenarios. So next steps. We want to focus on decoupling the authorization logic from the backend application, implementing upstream authority feature which basically means bring your own certificate and configure SPIRE directly through Tornjak portal. Implementing IAM for the Tornjak manager. This is not done yet, so we have to work on this. And that would allow secure management across multiple SPIRE instances and different trust domains. Auditability capabilities to achieve global visibility of workload, communication, and persisting the access control details from the centralized place. So please talk to us. Please join us. We are always available on SPIFFE community Slack under the Tornjak channel. In a few minutes, I'm going to post this presentation into the Slack channel as well. Our GitHub repo is under SPIFFE organization, and we also have a Tornjak YouTube channel. There are several videos regarding all this Tornjak operations, and we are adding some new ones soon as well. Let's see what else. Okay, well, lastly, huge thanks for this amazing community. You guys been very, very responsive, very supportive, helpful, and always accommodating. So big thank you to you all. Thank you. Any questions? Anything else we want to discuss?
I have a question on if Tornjak can be extended to add dynamic or configure dynamic ports for service integration with SPIRE. Let's say we have cloud services with SPIRE in an existing setup, and if we scale up adding multiple services with port configurations, I was curious if that feature could be added in the roadmap, or is that an area of interest to extend for Tornjak?
So Eli, you have to help all of us online with
Come closer.
question.
Yes, microphone is here.
Oh, yeah, great.
And they can see you.
Sure.
All right, awesome. Get in there.
So, yeah, great presentation. I was curious if Tornjak can be extended to do port configurations for new service addition into an existing configuration with SPIRE.
What do you mean by port configuration?
Like each service is configured to a particular port to open up the ports. So if Tornjak can also do the to basically configure the ports to talk to the SPIRE server.
Oh, okay, well, that's interesting. So it's not on our agenda right now, but that's an interesting use case. That's Sunny, right? Are you Sunny?
Yes.
Yes. Okay. Yes, I know you from Slack. Okay.
Yeah,
So, yeah, I'm happy to discuss this in details. If you want to, we have not considered this use case, but if there is something that you need, sure, we can work on it. We can.
Yeah, I guess that also brings into a more adding a discovery kind of feature in Tornjak to discover the existing services with SPIRE, outside SPIRE, not only with, yeah, so essentially what are the workloads which are interacting with SPIRE, and if we bring in a new workload, how that could be configured into the existing.
It feels like you want to turn SPIRE and Tornjak and Envoy into the service mesh.
Yeah, to put it in a context. Thanks, Eli. Yeah.
Well, the goal for us is to actually find some interesting use cases that are helpful to you, so we can improve the adoption and we can improve show some value in the community. So anything that you are interested, we're happy to consider. For now, we just showed what is on our short-term horizon. But of course, if you have some interesting use cases, we willing to listen.
Awesome. Thank you.
Sure.
I think we're good with questions on our end.
Okay, thank you.